Okay, in this video we're going to learn about what is a convex polygon, what is a concave or non-convex, not convex polygon, and what is a parallelogram. So if you look over here, I've drawn some examples of convex polygons. The triangle is a convex polygon, so is the square, so is the rectangle, so is the pentagon, and there are many others. Over here, you'll notice some examples of concave or non-convex polygons. So what's the difference? Well, if you notice where the arrows are pointing, they're pointing at the vertices of all these polygons. And the vertices of convex polygons look very, very different than the vertices of concave or non-convex polygons. Okay, look at this vertex. Look at that vertex. And let's look at, look at this vertex all the way over there. And look at this vertex right over here. So do you notice the difference? Yeah. And if you do notice it, what you'll notice is that convex polygons, all their vertices face outward, whereas concave polygons have some vertices that face outward, but also have vertices that face inward, like this vertex right there, and like this vertex right here. Okay? So now let's move on to parallelograms. Well, we know that you learned about parallel lines earlier in Unit 1, and you know that parallel lines will never, ever touch, no matter how far they go. So if parallel lines will never, ever touch, then when is a quadrilateral, a four-sided shape, or when is a quadrangle, a shape with four angles, a polygon, considered a parallelogram? Well, these quadrilaterals over here are considered parallelograms because their sides are different than these quadrilaterals that are not considered parallelogram. So again, remember, parallel lines never ever touch. So look at this rectangle over here. And if you notice this rectangle, if you notice this side, and now let's look at the opposite side. And you'll notice that the opposite sides of a rectangle will never, ever, ever touch. But is that true for all the opposite sides of a rectangle? So now let's look at the top and the bottom of a rectangle, and you'll notice that those sides will never, ever touch either. And that's why a rectangle is considered a parallelogram, because all of its opposite sides will never, ever, ever touch. So now let's see if the rhombus passes the test. Let's try with the rhombus. Look at the top of a rhombus, and then look at its opposite side. And you'll notice that the opposite side of a rhombus will never touch. Okay? Let's see if that's true for all opposite sides of a rhombus. Okay, let's look at this one. And let's look at the opposite side again. And again, you notice that the opposite sides of a rhombus will never ever touch. Now, let's look at this quadrilateral. It's called a parallelogram. And you notice at the bottom of the parallelogram and the top of the parallelogram will never ever touch the opposite sides. And if you notice these opposite sides, will also, this side will never, ever, ever touch this side. And that's why these shapes are considered parallelograms, because their opposite sides will never, ever, ever touch. However, the trapezoid and other quadrilaterals are sometimes not considered parallelograms because their sides will eventually touch. So look at the side of this parallelogram. You'll notice that if we extend it and we extend it right, all the way up, and then look at the opposite side, and we extend this side all the way up, you notice that eventually they will touch. So now I know what some of you are thinking, but the top and bottom won't. Yeah, the top and bottom won't, but in order for it to be considered a parallelogram, none of its opposite sides can ever, ever, ever touch. Okay, so let's look at this quadrilateral here, and let's see if its opposite sides will ever touch. Okay, let's look at the bottom, and let's extend it all the way as far as possible. Now, let's look at the top, and let's extend that as far as we can. Okay, and when you extend the top and the bottom of this quadrilateral, you'll notice that they don't touch up here, but when you keep going, they do eventually touch all the way down here. So to summarize, what's a convex polygon? It's a polygon where all the vertices face outward. What's a concave polygon? They're not convex. They have a vertex or vertices that face inward. Well, you already know that parallel lines will never ever touch. So a parallelogram is a quadrilateral or a quadrangle whose opposite sides will never touch. And if its opposite sides will eventually touch, then it's not considered a parallelogram. Good luck.